Okay, so we introduced in the previous video what a radical is and a little bit of working with them. Now we're going to start to talk about simplifying radicals. We need to simplify radicals because most radicals, like the examples there, do not have nice decimal values. If you go into a calculator and do any one of these, square root of 2, you're going to get 1.41 and then a whole bunch of other stuff. The decimal is going to continue on forever. Same thing with square root of 20, the cube root of 40, fourth root of 54. If you computed any one of those things, the decimal answer is going to be ugly. So, much like a lot of fractions have very ugly decimals, we'd like to simplify these as radicals. We'll keep them written as radicals so that we have an exact value. But just like fractions, we like to be able to simplify or reduce them down to fractions. We'd like to reduce them down to what we call lowest terms. With radicals, we'd like to reduce them down to a smaller radical. So that's what I just said. So we like to reduce them. A couple of things that we need. We're going to first focus on square roots in this video, and then in the next video we'll move on and talk about other roots. And right now we're talking about square roots with numbers. Later on we'll get into a discussion of square roots with variables involving exponents and how to handle that. Two things that we need. First, we need to know our perfect squares. You don't have to memorize these. All these come about is just taking each number from 1 upward times itself. So 1 is just 1 squared, 4 is just 2 times 2, 9 is 3 times 3, 16 is 4 times 4, so you can keep going up this list as much as you need to. The other thing we need is this property of roots. Now this works for any root, so I'm writing it as nth root. Specifically, it's going to work for our square roots, and that is that we can take a square root or any root of some multiplication problem and rewrite it as the root of each piece. For example, and you can check this on your calculator, if you were to compute square root of 50, you could do square root of 50, you'll get an answer, and then if you took square root of 5 times square root of 10, 5 times 10 is 50, so square root of 5 times square root of 10 will give you the same answer as square root of 50. So I would encourage you to maybe pause the video and kind of confirm that that does work, because we're going to make use of that property now. So let's consider square root of 20. Now, when we write this square root of 20, we want to rewrite it as a multiplication problem. But as we're doing that, we want to keep an eye to these perfect squares, because the only things that we can have where we take a square root and get a really nice answer is if we're doing square root of these numbers. So when we look at that 20, we say, well, 4 is a perfect square, so I could rewrite 20 as 4 times 5, and then using that multiplication property, could rewrite that as square root of 4 times the square root of 5, and then square root of 4, because it's a perfect square, can be simplified, and we get 2 square root of 5. Now you might want to again kind of confirm this on a calculator, so maybe pause the video and compute square root of 20 on a calculator. Compute 2 times square root of 5 on a calculator, and you'll see that you get the same answer both times. Okay, really important. When we do this rewriting it as a product, we must use a square. If I had rewritten 20 as square root of 10 times 2, that doesn't help me very much because I can't do square root of 10 and I can't do square root of 2. At least not to get a nice answer. So we have to find a square when we're factoring it. That's very important. Consider another example, square root of 75. So we begin looking at our list of squares and work our way up that list until we find something that will go into it. Now, if we go through that whole list and don't find anything that goes into it, then that means that thing can't be simplified. But in the case of square root of 75, we get up to 25, and when we get to 25, we find, hey, 25 is in a 75, So I can rewrite square root of 75 as square root of 25 times 3. Because 75 is 25 times 3. 25 is a square root, a perfect square. So we can do the square root of 25. And we get 5 square roots of 3. Okay, let's consider one more example in this video, and that's square root of 80. So again, you look through your list of perfect squares there until you find one that goes into 80. Now you may spot a different one. I'm going to do this one with 4 because I want to demonstrate something. 80 can be rewritten as 4 times 20. Now square root of 4 I can write as 2. And then that square root of 20 though can be broken down further. Because see, there's still another square that goes into that. So sometimes you may pick something and take it out, but there may be something more to take out. And so square root of 20 can be rewritten as 4 times 5. So I write square root of 4 times square root of 5. I can then simplify square root of 4 again and get 2. So now I have 2 times 2, which I can write as 4 and 4 square roots of 5. Now if instead of picking 4 as your perfect square, you had looked at your list and said, well, wait a minute, 16 works as well, well then you'd have written square root of 80 as 16 times 5. Square root of 16 is 4, and you'll still get 4 square roots of 5. So if you pick the biggest one, you'll have less extra steps to do, but just finding any perfect square will suffice because you can continue to simplify after that. Okay, in the next video we'll look at how to handle things like cube roots and other roots of numbers.